Section: Introduction. In this section, we discuss the nature of creative writing, emphasizing that there isn't just one correct way to respond to a prompt. For instance, if we are given the prompt, "Write a story about a dog on the moon," we can create many different stories, focusing on various aspects like the dog's adventures or its feelings of loneliness. This ability to think divergently is a key part of creative intelligence. When we train large language models, LLMs, for creative writing, it's important for these models to explore different paths and endings. Although methods like proximal policy optimization, PPO, and direct preference optimization, DPO, can enhance the quality of the outputs, they often reduce the diversity of the results. This lack of diversity can lead to repetitive and biased content, limiting the range of creative responses available to users. Previous studies have looked into ways to boost the diversity of LLM outputs, mainly focusing on how to optimize already trained models through techniques like prompting or adjusting sampling temperatures. Some research has attempted to tune models for diversity, but often only for simple tasks, such as generating baby names. Our work aims to improve output diversity in creative writing while maintaining quality by incorporating diversity into the training objectives. We introduce a concept called deviation, which measures how different a training instance is from other samples for the same prompt. We apply this deviation measure to enhance various post-training methods, creating diversified versions of DPO and odds ratio preference optimization, ORPO. Our findings show that these diversified approaches can increase both semantic and stylistic diversity without significantly compromising writing quality. Our models outperformed existing instruction-tuned models in terms of diversity while maintaining comparable quality. We also conducted human evaluations comparing our diversified DPO with the original DPO and GPT-4o, confirming that our method can produce diverse outputs without sacrificing quality. Additionally, we experimented with varying the number of training instances per prompt, demonstrating that our approach consistently boosts output diversity, except when there are too few instances, which can lead to quality issues. However, we found that these issues can be resolved by adjusting the objective function or using high-quality training instances. In the related work section, we note that while post-training methods like PPO, DPO, and ORPO have improved instruction following and output quality, they often result in lower diversity. Researchers have observed that this decreased diversity can lead to repetitive narratives in creative writing. To enhance diversity, some have suggested adjusting decoding methods, such as penalizing similar outputs during beam search or modifying sampling techniques. However, these adjustments often come with trade-offs between quality and diversity. We also highlight that while some studies have explored tuning LLMs for diversity, they typically focus on simple tasks. Our approach, which leverages deviation as part of the learning objective, aims to diversify creative writing generation while preserving quality. In the preliminaries, we outline the problem of creative writing generation and the metrics we will use. For creative writing tasks, given a prompt, we want LLMs to generate diverse and high-quality outputs, ensuring users receive various valid options. We define valid as whether the output meets the prompt's requirements. We formulate quality and diversity metrics based on the generated responses, using mean pairwise distance to evaluate diversity among the outputs. Section Summary. In this section, we discuss the importance of output diversity in creative writing generated by large language models, LLMs, and propose incorporating deviation into post-training methods to enhance both diversity and quality. Our approach, which includes diversified versions of existing optimization techniques, demonstrates improved diversity without significantly compromising writing quality, outperforming current models in generating varied and high-quality creative outputs. Section: Post-training approaches. In this section, we discuss post-training approaches. Since post-training can be noisy with limited samples, some methods, like direct preference optimization, DPO, require supervised fine-tuning to help models generate the desired outputs. DPO directly optimizes the policy model using a dataset of input-output pairs, increasing the chances of preferred outputs over less desirable ones. We use the ratio of the policy model's likelihood to that of a reference model as an implicit reward, guiding our training objective. We also introduce a method to enhance both quality and diversity in post-training by incorporating deviation into our objective function. Deviation measures how much a training instance differs from others with the same prompt. By including this factor, we aim to encourage models to produce high-quality outputs that are less typical. We assume there are enough prompts with multiple responses to make this concept meaningful. For diversified DPO, DDPO, we adjust the training objective for each winning-losing response pair by weighting it with the deviation of the winning instance. This emphasizes rare winning responses more than common ones. Similarly, for diversified ORPO, DORPO, we extend our approach by weighting both the log likelihood and log odds ratio terms with the deviation of winning instances. Our dataset focuses on creative writing, sourced from the R-Writing Prompt subreddit, where users post prompts and share their creative responses. This allows us to train a model that generates diverse outputs for the same prompt. Each response has a user upvote score, which we use to train a reward model and create a binary preference dataset for training generation models. We split the data into training and testing sets, with specific details provided in the appendix. To evaluate quality and diversity, we sampled 4 instances for each evaluation prompt and measured their quality and diversity. We used 1,000 prompts from the test dataset, resulting in 4,000 samples. Our evaluation included automatic assessments of output quality and diversity. For quality, we trained a regression model to predict upvote scores based on input-output pairs. For diversity, we calculated mean pairwise cosine distances between samples, focusing on semantic and style diversity using specific embedding models. For DDPO and DORPO, we calculated the deviation for each instance, focusing on both semantic and style deviations. We ensured that deviations were non-negative and summed to match the number of instances per prompt. We also explored combining semantic and style deviations to enhance diversity in training. Further details on deviation calculations can be found in the appendix. Section Summary. In this section, we discuss post-training methods like direct preference optimization, DPO, and its diversified variants, DDPO and DORPO, which enhance model performance by optimizing response quality and diversity based on user-generated writing prompts. We also outline our evaluation approach using a dataset from R-Writing Prompts, focusing on measuring the quality and diversity of generated outputs through various metrics and embedding techniques. Section Conditions. In this section, we examine several baseline models, including SFT, DPO, and ORPO. We also looked at post-trained versions of base models, such as Instruct, and 4 other instruction-tuned models: GPT-4o from November 20, 2024, GPT-4o from December 17, 2024, CLAUDE 3.5 Sonnet from October 22, 2024, and DeepSeek R1. For GPT-4o, we tested an iterative prompting method to see if we could achieve diverse outputs by asking the model to generate results that were significantly different from previous ones. We calculated metrics for the original test dataset, referred to as GOLD. For DDPO and DORPO, we analyzed versions focusing on either semantic deviation or style deviation, as well as those considering both types. We started with pre-trained models, specifically LLaMA 3.1 to 8b and Mistral 7b v0.3. We applied parameter-efficient tuning using LoRA, optimizing low-rank additions to weight matrices, which allows us to fine-tune large language models effectively. We initially trained SFT models to serve as a foundation for DPO training, using a cosine learning rate schedule and the Atom optimizer for a single epoch with a small batch size. We saved evaluation checkpoints regularly and selected models based on the lowest evaluation loss. All training was conducted using Accelerate and DeepSpeed 02 in a specific format across multiple GPUs. For DPO, DDPO, ORPO, and DORPO, we trained models with a fixed dataset in offline settings, using a linear learning rate. The batch sizes varied, particularly for DPO and DDPO on Mistral 7B due to memory constraints. We trained DPO and DDPO for 3 epochs and ORPO and DORPO for 4 epochs, starting from the base model. Our results indicated that existing instruction-tuned models clustered together, showing high rewards but low diversity, which aligns with previous findings. In contrast, human-crafted gold had lower reward scores but significantly higher diversity. SFT models had the lowest reward scores, yet their diversity was better than existing instruction-tuned models but still lower than gold. Both DPO and ORPO improved reward scores compared to SFT, although they either maintained or reduced diversity. Notably, our trained models exhibited higher diversity than existing models, likely due to the varied responses in our training dataset. Our approach effectively promoted targeted diversity while only slightly reducing quality. DDPO models increased semantic and style diversity, and the DDPO both model combined both types of deviations. In terms of quality, some DDPO models showed decreased quality compared to DPO, while others maintained or improved quality. DORPO models followed similar trends, increasing targeted diversity with minimal impact on rewards. Among our trained models, the DDPO both model based on LLAMA 3.1 to 8B achieved high scores in both quality and diversity, closely matching the best baseline and gold data. We provide examples of conditions in a table and additional summaries in the appendix. Section Summary. In this section, we evaluated various instruction-tuned models and training methods, including SFT, DPO, and ORPO, focusing on their writing quality and diversity. Our findings indicate that while existing models generally exhibit high rewards with low diversity, our trained models, particularly the DDPO both variant, achieved a balance of quality and diversity, outperforming many baselines and demonstrating the effectiveness of our approach in promoting targeted diversity. Section: Human Evaluation. In this section, we complement our automated evaluation with a human assessment on a selected set of conditions. We present 2 groups of texts from different conditions, and evaluators determine which group contains the most interesting and high-quality writing, as well as which is more diverse. If they find it hard to choose, they can select a hard to decide option. Each group consists of 4 creative pieces generated by our model for that condition. We provide summarized versions to avoid overwhelming the evaluators with too much lengthy text. Through this human evaluation, we focus on measuring semantic diversity, but not style diversity. 5 authors from our paper acted as evaluators, remaining unaware of the conditions. 3 evaluators assessed each instance, and we combined their votes using majority voting. This method allowed us to compare DDPO both against DPO and GPT-4o against DDPO both. We chose to compare with GPT-4o because of its popularity in large language model research and its straightforward prompting. In our results, evaluators frequently selected the sets from DDPO both as having the highest quality stories compared to GPT-4o, with a significant difference in ratios. When comparing DDPO both to DPO, it was chosen more often, but the difference was not significant. For diversity, DDPO both sets were also chosen more often as more diverse compared to both GPT-4o and DPO, with significant differences in both cases. Evaluator agreement was fair, with scores indicating that quality agreement was moderate, while diversity agreement varied significantly between the 2 comparisons. We also conducted an ablation study to see if our approaches would still be effective with a smaller dataset, as creating a large dataset can be costly. We compared DDPO both to DPO with varying numbers of responses per prompt, from 4 to the maximum available. We also compared our methods to a recent approach called DIVPO, which requires filtering based on quality and diversity. When we limited the number of responses, we could apply DIVPO's filtering. Our results showed that, except when the maximum number of responses was 4, DDPO both had similar or slightly lower average rewards compared to DPO and DIVPO, while maintaining higher diversity. DIVPO had slightly better diversity scores than DPO, except for semantic diversity when the maximum number of instances was 12. Overall, our approach proved more effective in promoting diversity without significantly compromising quality, except when there were too few responses. We hypothesized that the drop in rewards when the maximum number of responses was 4 might be due to instances where the calculated value was 0. We explored whether setting a minimum value for this calculation could improve performance. By replacing values below a certain threshold, we found that it increased rewards to match DPO's level while slightly reducing the boost in diversity. However, DDPO both still outperformed DPO and DIVPO in diversity. We also investigated whether using higher quality winning responses would help. When we sampled only the best responses, we achieved higher average rewards than DPO and nearly matched DIVPO, although both types of diversity decreased. Overall, by adjusting our calculations or using high-quality data, we could improve DDPO's generation quality with fewer responses, but this came at the cost of diversity. Despite this, DDPO still maintained higher diversity than both DPO and DIVPO. Section Summary. In this section, we conducted human evaluations alongside automated assessments to compare the quality and diversity of creative writings generated by different models, finding that DDPO both was preferred over GPT-4o and DPO for both quality and diversity. Additionally, we explored the impact of varying the number of responses per prompt on model performance, demonstrating that while DDPO both maintained higher diversity, adjustments to the generation process could enhance quality without significantly sacrificing diversity. Section: Concluding Discussion. In this section, we present our concluding discussion. We introduced extended versions of DPO and ORPO in a creative writing context to enhance diversity while ensuring high-quality generation. Our main idea was to consider how much each successful instance deviates from loss terms. With these methods, we created a model that matches the quality of leading models and achieves diversity similar to original human-created datasets. We also showed that our methods are resilient to changes in dataset size and outperform an existing method called DIVPO, which requires more data instances than what is used for training since it filters data. In contrast, our approach makes full use of the available dataset, which is particularly beneficial in situations where data is limited. Overall, we emphasize that achieving generation diversity requires a balance between learning from both common and rare high-quality training examples. While we demonstrated the advantages of our approach in our specific context, it is crucial to validate it in other settings. Many instruction-tuned models with low output diversity have been trained using online methods, so future research should explore whether our approach can help address these issues in online training environments. Additionally, we should investigate diversifying tuning methods for tasks beyond creative writing. We also noted that there are various ways to configure the deviation term, and further exploration of these options could be valuable. Since we use deviation terms with winning and losing response pairs, future work could look into how to apply deviation terms in tuning methods that do not rely on these pairs, such as those that utilize numerical rewards.